Jupiter is the largest planet in our solar system. But what if, one day, it simply vanished? Welcome to this explainer. Today we're jumping straight into a massive, scientifically accurate thought experiment about our solar system's reigning gas giant.
Okay, let's dive right into this. Think about it for a second. Would Earth be thrown completely out of its orbit? Would we suddenly be attacked by a barrage of asteroids? And what in the world would actually happen to Jupiter's moons? All right, before we explore all that chaos, we gotta set some ground rules. In this thought experiment, we're assuming Jupiter just disappears. Instantly. Its massive mass, its incredible gravitational influence, gone in a single second. Meanwhile, the rest of the solar system initially remains completely unchanged. Now, I want to be absolutely perfectly clear here. This is strictly a hypothetical scenario. This literally cannot happen in reality. But, exploring this completely impossible event, it's absolutely the best way to understand the very real physics holding our cosmic neighborhood together. So, to kick things off, why does Jupiter's gravity matter so much in the first place?
Well, to understand the sheer scale of what we're losing here, we just have to look at the numbers. Jupiter is massive. And I mean massive. It is more than twice as massive as all the other planets in our solar system combined. Think about that. If Earth were the size of a grape, Jupiter would be a giant basketball. And because it has such an enormous mass, it strongly dictates the movements of just countless other objects around it.
Which brings us to the biggest, probably most terrifying myth out there. If Jupiter vanishes, does Earth get flung out of its orbit?
With that massive gravitational anchor suddenly gone, would Earth immediately fly out into deep space? The answer is a definitive, resounding no. Earth would absolutely not be instantly destroyed or hurled into the dark void. While Jupiter definitely influences our orbit, our planet is primarily, and very strongly, bound to the Sun.
And the reason for that is actually super simple. The Sun completely, utterly dominates the orbital motion of the planets. It holds a staggering 99.85% of all the mass in the entire solar system. So yeah, Jupiter might be the undisputed king of the planets, but compared to the Sun, it's just a tiny fraction of a percent.
It basically all comes down to Kepler's first law. Every planet's orbit is an ellipse, with the Sun sitting right there at one focus. Our primary gravitational tether is fundamentally tied to the Sun, not Jupiter. So, without Jupiter, Earth's orbit around the Sun stays basically intact. We are not immediately flying away anywhere.
But hey, while Earth is safe in the short term, the immediate neighborhood around Jupiter, that is a wildly different story.
See, Jupiter basically forms a miniature solar system all on its own. It's got 95 officially recognized moons, all tightly bound by its gravity. We're talking about the 4 massive Galilean moons here: the intensely volcanic Io, the icy subsurface ocean world of Europa, Ganymede, which, fun fact, is actually bigger than the planet Mercury, and heavily cratered Callista. The exact second Jupiter vanishes, that incredibly powerful gravitational tether holding those 95 moons is instantly severed. Their orbits around Jupiter? Gone. Just completely erased.
Now you might be wondering, do they just stop in their tracks? No way. They wouldn't just freeze in place. Their new paths would depend strictly on their exact positions and their velocities at the very microsecond of that disappearance. Stripped of Jupiter, they would just shoot off, set adrift on brand new paths, suddenly becoming their own independent objects orbiting the Sun. All right, let's zoom out a bit to the asteroid belt and comets. This brings up the whole cosmic shield theory.
People always ask, without Jupiter, would Earth suddenly become a more dangerous place? Would more of these objects hit us? Well, the idea that Jupiter is just this perfect, protective, cosmic shield for Earth is actually a huge myth. The reality is much closer to a giant cosmic pinball flipper. It is incredibly complicated. See, Jupiter's gravity is a total double-edged sword. Yes, it absolutely deflects some objects away from us, and it captures some completely. But it also alters orbits through these complex gravitational perturbations and resonances. It actively flings some objects directly toward the inner solar system. So removing Jupiter would gradually, not instantly, but gradually, change the entire dynamical structure of these small body populations.
And we've literally witnessed Jupiter capturing massive objects in real time. Back in 1994, comet Shoemaker-Levy 9 got drawn in and smashed violently into Jupiter's atmosphere. It's solid proof of Jupiter's immense reach. But without Jupiter, while we definitely miss out on it taking those hits for us, we'd also stop having objects hurled our way by its gravity. The entire threat profile for Earth just completely shifts.
So that's the local stuff. But what about the long-term, slow-motion gravitational ballet of the planets?
is absolutely vital to understand the timescales involved here. At +1 second, the moons are instantly lost. Boom. Over the next few years and decades, comets and asteroids start lacking that deflection. But it's really over millions of years that the planetary orbits themselves start to experience uncorrected gravitational perturbations.
Just think about how fast the planets are screaming through space. Earth alone is cruising at over 107,000 kilometers an hour. These immense speeds, perfectly balanced against the sun's gravity, are what keep us in orbit. But here's the thing. All the planets constantly give each other these tiny gravitational tugs. Without Jupiter's massive presence balancing those tugs out, the intricate dynamics of these orbits would slowly, over eons, totally rewrite themselves. In fact, we know from studying the early solar system that Jupiter has actually done this before. A period of shifting orbits between Jupiter and Saturn likely scattered Uranus and Neptune out to where they are today, and it heavily shaped the Kuiper Belt and the asteroid belt. Jupiter's gravity historically organized the very architecture of our planetary neighborhood.
So, after breaking all of this down, what's the biggest cosmic surprise of a Jupiter-less system?
Bringing all the science together, we hit this really profound realization. The biggest surprise of this apocalyptic thought experiment is actually kind of quiet. Earth would not immediately be destroyed. We would survive the initial event, which totally debunks all those dramatic myths of our planet instantly plunging into the dark.
The true aftermath is just so much more complex and fascinating. Earth, along with the other planets, stays firmly bound to the sun. The 95 moons of Jupiter, they become solitary travelers set adrift on new solar orbits. The whole asteroid and comet threat profile shifts completely. And ultimately, the gravitational architecture of the entire solar system is slowly but irreversibly rewritten over millions of years.
This right here is exactly why astronomers study Jupiter so closely. It's the key to understanding how planetary systems evolve. Which leaves us with this final thought. If removing just one planet slowly rewrites our entire solar system, what hidden gravitational dances are constantly shaping the thousands of exoplanet star systems we're discovering out in the galaxy right now? Thank you so much for exploring the science with me on this explainer today. Keep looking up and stay curious.